Okay, welcome, Jacqueline and Tandia and Ross and Zach and Alejandra and Bailey and Juliana and Nicholas and Constance. Thanks for coming. Today is probably be a little bit shorter webinar than we usually have because one thing is I want you to really focus on what's coming up, and there's two main things coming up this week. One is Project One, and that's a huge part of your grade, so take it really seriously. Really got to do well on that. The other is the online midterm, or the online exam. I moved that one up to this week because I realized it covers chapter 6, and we're doing chapter 6 this week. So there's two main things that are happening. The good news is that chapter 6 is maybe the easiest chapter. So it's kind of like a break in new stuff so that you can do the project and the online exam. It's not a nothing chapter, it's an important chapter, but no one ever complains about it. Okay, you might be first to complain, I don't know, but it's not one that everyone has issues with. So we will talk about chapter 6. Chapter 6 is about the normal distribution. If you remember last week, we talked about the uniform distribution, and I mentioned that's the easiest one to use mathematically, but it's not all that useful. It doesn't happen that often. The normal distribution is the exact opposite. It's brutal to use, but it's used all the time. But the good news is all the brutal parts happen in your calculator and you'll never notice it. But if you're one of those like me and you're geeky and you want to learn the math behind it, beware. It's really, really hard. So you don't have to know the math behind it, but you have to know how to draw pictures, and you have to know how to sketch areas like you did with the uniform distribution, very similar to that, just so you can draw it. And then you have to understand the picture. That's all. Otherwise, it's not too bad. So let me ask you, are there any questions about anything? This is your chance. Any questions? That could be the project, could be the online exam, it could be about, I don't know, something else. The midterm's not for a while, but you might be interested, I don't know. Because we're in week 4. So week 4 is kind of like the two big things happening. On average, how long you expect the paper to be? 1 to 2 pages is not going to work for you. It's usually around 8 to 10 pages. So it's a paper. Okay, that's why I talked about it 2 weeks ago. If it was 1 to 2 pages, I could have told you now, and I could have told you on Saturday and said go do it on Sunday. No, this is one it is a project, not a paper, for one thing. So it's long. Now, part of those pages are graphs and copies of the spreadsheet, which, by the way, it is required to have a copy of the statistics part of the spreadsheet. Okay, you will lose at least a whole grade if you don't have that. All you do is copy and paste, but you have to use a spreadsheet. You cannot use a calculator. You shouldn't even mention a calculator. Variance is not very important. We haven't talked about it. There's a lot of statistics on that spreadsheet, which we really haven't talked about, and variance is one of them. But standard deviation, that one's a biggie. Okay, so the things you should have a lot of standard deviation is the number 1. You should also have the quartiles. You should have the mean. You should have the median. You should talk about the max and the min. You should investigate important z-scores. Okay, you should also look at the interquartile range. So there are a lot of statistics, but not variance. So Jacqueline, absolutely not. You cannot use those words. And it's the first word that you're not allowed to use, the word we. Okay, so you can't say we. You can either refer to yourselves as the researchers, or you can use a tense where you don't have to use we. So the results were, for example, and then you're not saying we did anything. This is not about you, so you shouldn't name yourself. You shouldn't use we or us or our. None of those words are allowed. Okay. When you say The charts you should definitely have, but what I'm saying, that's not the spreadsheet part. The spreadsheet part is, so let me share my desktop. I think that's the best way, and I'll just show you. I mentioned it a while back, but you know how it is. 2 weeks will do amazing things to memory, right? So when I went, remember I spent like a half an hour talking about the project? So it's in there, but why don't I, so it'll take a second to get into it. And then I gotta share my, just a second. Let's go ahead and do a share. Okay, so the part to copy and paste is pretty much columns C and D. Okay, pretty much you only have to go up to the Z-score. Maybe IQR if you want. So we do IQR. I guess maybe you can just do the whole thing. It's easy to copy. Just copy and paste. Okay, and if for some reason that doesn't work, do a screenshot of that part. So does that make sense? Okay, the charts, those you should also have in your paper. Okay, because you want to refer to them, and it's hard to refer to them if they're not there. But these are the statistics. Do not say you used your calculator. Let's see what else. We send you the Google Sheets doc. Yeah, or just copy and paste it right into your paper. That's the easiest. Yeah, so again, column C, yeah, so those are the parts you copy and paste in. Again, if we haven't talked about it in class, don't talk about it in your project. If you think you understand kurtosis, you're wrong. Okay, there's a lot of things we don't do in this class, but there's a lot we do. Yeah, so you need to send me the rough draft pretty much by Wednesday night. And I want to remind you, my calendar, unfortunately, I mentioned this last week, but I want to tell you again, I am in charge of an entire big workshop for all of California on Saturday, and I can't be online to be an instructor on Saturday. So don't expect any help basically on Saturday. Sorry about that, but that kind of stuff happens. I'm going to be in charge of like 100 people from all over California learning about how to best learn about statistics and pre-statistics. So it's going to be a challenge. And I'm not going to be able to just chop in and say, oh, I got to wait a bit because I got to help my students. I can't do that. Okay, so, but I will be online. Definitely Thursday is my day that I'm going to read your project drafts, and I'm going to do it first come, first serve. So the first one that came in on Wednesday or Tuesday, or I guess tonight could happen too, that one I'll read first and give the first feedback. So I think that's fair. And the one that comes in last by Wednesday night, that's the last one to get looked at. And that could possibly, that could be Friday if I don't finish by Thursday, because it's a lot of you and it's a lot of reading. But pretty much almost my whole day will go towards that. Okay, other questions? Let's see if we got more. Just watch it again. Yeah, let's see, spreadsheet. I think I got all the questions. Yes, any other questions? Okay, and I want to remind you also the online exam that's due this on Sunday. It's much longer than the regular quizzes, but it comes from the same problems. So it randomizes out of those problems, grabs a bunch of problems. The big difference is you only get one shot. So if you get that problem wrong, then you got to live with that fact that you lose those points. So it's very long, but you only try once each. So if you wanted to practice, you can always practice by doing some past tests. I also, yeah, you could definitely take a break. There's no timer on it. Okay, but it has to be done by Sunday night. Don't wait till Sunday night, it's long. But you can definitely take a break, not a problem. Okay, any other questions on it? Okay, I do recommend that you finish the Chapter 6 assignment before you go and start the online exam, because the online exam covers Chapter 6, and again, it comes from the same problem pool. So you might even see the same problem with different numbers. So you want to have that practice in first. Any other questions before we jump into some working problems out? Okay, if there aren't, let me do a new share and let's go to a question. There it is. Okay, so here's the question, and I don't know if I'll do all these parts, but we'll do some of them at least. Do not use a calculator for this problem. Suppose that Z follows a standard normal distribution. So let me tell you what that means first. And I want to mention a few things. First is I want to draw a picture. Picture is really important. And I'm using a mouse, so it's not the easiest to do, but I'll do my best. That one's not too bad. Okay, so another word for the standard normal distribution, which I don't want you to use, is bell curve. I want you to use the word normal, because that's the statistics word for bell curve. So this is a standard normal distribution. One main thing about it, and this has to do with the word standard. When we're looking at the standard normal distribution, then the mean is always at 0. Okay? Turns out if you're looking at a general normal distribution, the mean could be anything. But for standard, the mean is 0. And the standard deviation is 1. Okay? And the way you write that, let me write this. I don't think I did it for the uniform because the uniform has some similar notation. Is we say Z, again, we use this letter Z, then you put a tilde. N stands for normal, and then you write down the mean of the distribution, which in this case is 0, and then you write the standard deviation, which is 1. Okay, and that, and I'm not going to use the word if, I'm going to use the word when. When I ask for this on the midterm, and remember, midterm is high stakes, and on the final exam. Those are the two biggest parts of this whole class. I'm going to ask you to write down the distribution, and this is the notation you're going to use. You may not use Z. There's other things that happen next week. You're going to use a tilde and an N. Then you're going to write down the mean. It may not be 0 when you know, on the problem you're working on. And then you write down the standard deviation, which may not be 1 on the problem you're working on. Okay? And we'll get there in a little bit too on the next question. Okay, so if I ask, write down the distribution, this is what you must write down. Okay? There's going to be different numbers and stuff and different letters, but it's that notation. Tilde. So what does tilde mean? Tilde means has the distribution of. And that's what that tilde means. That's how you read the tilde in long amounts of words. Sometimes you'll say follows the normal distribution in this case. And that's what tilde is. And this week is not going to be obvious why things follow the normal distribution and why this is the most important thing there is in the entire class, but it is. So next week we'll have a big theorem that says everything we ever do has a normal distribution. Okay, if we do things right in terms of statistics, but that's next week. So right now you just have to, you know, chill a bit and say, yeah, this is going to be important, even though I don't understand why. But I do promise you it's really important. Okay, let me give you some more things that we need to know. In this distribution, if you go one standard deviation, which is about there and about there, and you look at the area in between -1 and 1, so z-score is between -1 and 1, then that's about 0.68. And we've seen that number before. Where have you seen that number? A little while ago, a few chapters ago. Yeah, that was the empirical rule. That within one standard deviation, if you have a bell-shaped or normal distribution, you get 68%. Okay, similarly, now let's continue on the empirical rule. If you go from -2 to 2, let me change the color so you can see it well. -2 to 2, then all of that is, from the empirical rule, 0.95, or 95%. Any questions on that? Okay, similarly, if you go from -3 to 3, let's do that. It's way out here. That's 0.997, or 99.7%. So almost all of it. Any questions on this? Any questions? Okay, so you should all tell me in your chat box, what is the probability that z is between -1 and 1? I know the chart is busy, but it's there. That's a hint. Yeah, so that's 0.68. So that's an easy answer. I hope that's easy for everyone because it's just written there. So the answer is 0.68 for first one. Any questions on that? Okay, what's the probability that it's less than 3? Okay, well, to find the probability that it's less than 3, we know that in between -3 and 3 is 0.997. What is the whole area? So you tell me what it is from -infinity to infinity, given those are probabilities we're talking about. Yeah, it's 1, right? Not 99, 1. Okay? There's a 100% chance that it's going to land somewhere. Do you see that? So it's 1. So the whole area is 1. If between -3 and 3 is 0.997, then outside is going to be 1 minus 0.97. That's the rule of complements. So the first thing is I'm going to look at outside. And I'm going to have 1 minus 0.997. Any questions so far? Not the answer, but it's going to help us. The problem is the outside includes the left and the right. We want less than 3. So if we know how much it is on left and right, and we only want the left, what do we do? What's your thought? Can all chime in? Yeah, we divide by 2 because if both left and right together are 1 minus 0.997, then just the left is half of that because of symmetry. And the normal distribution is a symmetric curve. I tried to make it, my drawing as symmetric as possible. I'm not the perfect artist. I'm a terrible artist, but you could use your imagination at least. Okay, so what we can do now is put a 1/2 out there. And there's your answer. And you can drop that in, you can do the arithmetic. That's 0.00 0.15, if you work that out. Any questions on that? Okay, again, I'm not going to do all of these because I want to get to some other things too. But any questions? Okay, let's look at the 16th percentile. So I'm going to draw the picture again. It got too messy. So let's draw the picture again. And let's do part E. Okay, if we want the 16th percentile, what does that mean? What does that mean? Do you remember what it means to be a percentile? You can say it or drop in your chat box, either way. It's a probability, but in terms of the picture, what does it mean? Far left, kind of far left, not that far. Okay, what it means is that if you draw that line right there at the 16th percentile, let's just call that X. We don't know what it is, so we'll call it X, and we'll figure it out.
Can you turn that down?
And what we can say is the area to the left is 0.16.
I don't really care. It's not even 14 days, it's only 13.
Any questions on that? Any questions? By the way, if you're one of those that has talking in the background and you're not muted, please mute yourself.
All right, let me do it. Bye.
And then you can unmute when you have questions. Any questions about that so far? So that's 0.16. So the idea on this is we don't have a number that's 0.16, but that's okay, because what we can do is we can draw the other side of the picture and say that's also 0.16. How do we find the area in the middle if we know the left is 0.16 and the right is 0.16? What's the middle? Yeah, it's going to be 1 minus 0.32, or 1 minus 2 times 0.16, 1 minus 2 of the 0.16s. And that is equal to 0.68. And now we can tell what is the 16th percentile. So what is that value of X? And the hint is just look at the picture. You can't have an area that's negative. You can't have an area that's negative 0.68, right? That doesn't make any sense. These are areas. So I'm not sure how you got the negative, but 1 minus 2 times 0.16 is 0.68. Oh, that's a decimal point. That might be what you're having trouble with. I'll make the point more circular. Ah, Z. One more time. That might help. Yeah, I'm using a mouse, so it's not the perfect writing. Okay, so that, from the picture, if you look what X is on the left with that 0.68, and that's -1. So the answer to D is that to E is the 16th percentile, is that Z equals -1. Any questions on that? Any questions? Okay, let's do another problem. I don't want to do all of these because, again, I don't want to take an hour and a half for all of this. Let's get a bunch of problems done. Okay, so let's get rid of that. Go to select. There we go. And I'm not following where the Z equals -1 came from. So let me put a little arrow. That might help. One more time. Gonna get to the brush. See in the picture, the -1, Russ? And you see that the red corresponded to the area of 0.68? So our picture has to be the same. So if the 0.68 is in the middle, we must have -1 because it has to follow this normal curve diagram. Ross, does that make sense? Yeah, so it comes from this picture that we have as established. Okay, so now let's change a bit. Now let me get back to erasing. By the way, last chance if you have another question, because it's about to get erased. Gone once, twice, gone. Almost all it's gone. One more little bit of gone. Now it's gone. Okay, so let's do another problem. Let me pull it up. And we'll do some of these. I'm just copying and pasting a long list that I've got. Okay. So now it says use your calculator for this problem. We still need to draw a picture because I do want you to draw pictures. And on your midterm and final, you have to draw pictures when there's a normal curve. So make sure you can do that because I'll have you do that for the test. Suppose X follows a normal distribution. Notice the word standard is not there. So that means the mean is not 0 and the standard deviation is not 1. The mean is 114 and the standard deviation is 23. So first thing, just after reading that, it's a good idea to write down how do you write down the distribution? Let's see if you can write it down. Put it in your chat box. Write down the distribution. Remember, there were some symbols. Not seeing you put it all in the chat box, but you should put it in your chat box. Close, very close. Except I even gave you a hint because I typed it out first. It's X, not Z. Z is when it's standard normal, X is when it's just regular normal. So it's X tilde N, and then it's 91. Let's see. No, not 91, 114. Not sure where you got those numbers. That's interesting. 114, because that's the mean, because that's given. I have no idea where the 91 and 137 came from. Yeah, Nicholas has it. And then comma 23. Good, Bailey's got it. Any questions on that? Okay, so make sure, Crystal, you understand if it's not a standard normal, if it's a general normal, then we're talking X and we don't have a 0, 1, we have the mean and standard deviation, whatever those are. Okay, we want to find the probability that X is between 100 and 120. So what I'm going to do is I'm going to draw a picture. Same picture we always draw. And that is a normal curve. And we want to go from let's see, we want to go from 100 to 120. And notice it's on both sides of the mean. Okay, and the mean, by the way, was 114. And what we want is we want the middle area because of the x's between those two. Any questions so far? Okay, now I recommend following me. I'm about to reshare with the calculator because now we're going to find this probability using our calculator, which is quite easy actually, if you know how to do it. So let's go to the calculator. Let's clear what we had last week. And in the calculator, what we're going to do is we're going to go to second distribution. We've seen this before when we did the binom CDF and the binom PDF. So let me criticize the calculator. I always like to do that. This first one, normal PDF, if you ever use it, think again, you're doing it wrong. I don't know why they put this as the first one because that's usually the easiest. It turns out the second one is we want, which is normal CDF. So we get a normal CDF because we want a probability of between numbers. I hit enter. And this kind of calculator asks for lower, upper, mu, and sigma. My lower number was 100. My upper number was 120. My mu was 114. And my sigma was 23. Any questions? I got to paste and I hit enter. Now, if you have the older version or the TI-83, then it's just going to say normal CDF and you just type in what I have. It's always in order, lower, upper, mean, standard deviation, and put commas between. And then I hit enter. And there we have about 33% or 0.33-ish. If they ask you for 4 decimal places on the computer, it'll be 0.3315. Any questions on that? Any questions? Okay, so let me go back to the question again. I'll also fill it in. That's 0.3315, I believe. Any questions on that? Okay, let's do the next one. Now we have x greater than 200. So let me draw it. And as I mentioned, you're going to have to draw it. That's a requirement. So practice. Still have 114. We want x greater than 200. Like so. Any questions so far? Okay, so now we can go to our calculator. So let's go back. And there's the calculator. We're going to go second distribution again. Normal CDF, just like before. Okay, and our lower is going to be 200. What's the upper? How far right did it go? Yeah, infinity, and unfortunately you don't really have infinity in the calculator. So what you do is as long as it's much, much bigger than the lower, so and the mean and standard deviation. Notice that the mean, the standard deviation, and the lower are no more than 3 digits each. So I like to add 2 more and put 9s in. So 5 9s, 1, 2, 3, 4, 5, and that'll work. And that'll act like infinity. Then our mean was 114, standard deviation was still 23, and I hit paste. And enter. Okay, is the probability 9.2357? Is that the probability? Yeah, it can't be. Probabilities are never bigger than 1. So please never answer a probability question with a number bigger than 1. What's wrong? Because our calculator reads this. So what's wrong with what I said? The 9.2357. What do y'all see? Yeah, see that E -5? That means we have to move the decimal left 5 places. The first place just moves it on the other side of the 9. The other 4 gives you zeros. So the answer to this is, I'm gonna write 0 point and then 4 zeros. 1, 2, 3, 4. 9, 2, 3, 5, 7. Or 9, 2, 3, how about 6? I'll round to 4 decimals. 4 significant digits. Any questions on that? Any questions? Okay, let's take a look at it again. Look at a different one. I'm not going to do all of them, I'm going to do some of them. All right, let's look at the part E. And that is find the IQR. Do you guys remember what IQR means? While you're thinking, I'll draw the picture. Is D different than A? Yes. Yeah. D is a chapter 3 problem. But let me do IQR first. Right, IQR is the interquartile range, so it's 25% to 75%. So I'm gonna draw the picture. Again, the mean is 114. And what we have here is the first quartile's around there, the third quartile's around there, and we know that this area is 0.5, but more importantly, this area here is 0.25. And I want to find X. Any questions on how I drew that picture? Okay, I need to find that X, and maybe I'll call this guy Y. I need to find Y also. Any questions on this? Okay, so once we have that, now we can go ahead and use our calculator. Let me show you how you do this. Notice to find X, it's backwards, right? And the other problems, we knew the area we wanted to, we knew the X, we wanted to find the area. Now we know the area, we want to find the X. So it's exactly in reverse of the other type. Now, I have a question for you. See if you can remember your math. If you have a function and you want to do it in reverse, what do you call it? What do you call that function if you can do that function backwards in reverse? Yeah, it's called the inverse. So if you keep that in mind, this won't be that hard. So let's go ahead and go to the calculator. That is, there it is. Nope, that's not it. There it is. Okay, so here's the calculator again. I am again going to go to second distribution. And I'm not going to go normal CDF. I'm going inverse norm, because we want the inverse. Inv norm stands for the inverse normal distribution. And I hit enter. They ask you for the area, that's 0.25. They ask you for the mean, which was 114. They ask you for the standard deviation, which was 23. And then just hit paste. And then enter. Any questions so far? We're not done yet. Any questions? Oh, you know what? I think it multiplied by 0.0999. Let's start again. I had to clear. Let's try one more time. It didn't do it right because I still had that 0.0999 or whatever, 0009. So I'm going to go to second distribution one more time, and it'll just do it for us. Enter. Should all be in there. Paste. and then enter. There we go. It's 98.4867. By the way, with the picture, you would know that was wrong because you know it can't be near 0. Yeah, that's why I ignored the tail, because most of them don't say tail. Do you notice I didn't say anything, Ross? So yeah, just keep it left and you'll be good, because if you don't have it, then you'll just know it's always left. So I only show that way. Only the TI-84 plus CE style. There's all these styles of the TI-84s. Okay, now we need to do the same thing, but we need the 75th percentile, right? So the nice thing is I could just go second entry. This is a little, I don't know if you've seen this before, but all we need to do is change that 25 to 75, and then change the 2 to a 7. So I go over to the 2, make it a 7. Hit enter. Any questions on what I just did? It's kind of tricky. You could do it using the second distribution and do the whole thing, but this is a whole lot easier. Then the IQR is the difference between the two. So we take the 129.5133 minus the 98.6736, sorry, 4867. And there's your IQR, 31.0266. I don't know how to put after 23. Don't worry about the left. It's not going to be there on your calculator. So it's going to be 0.75, comma 114, comma 23, and the parenthesis, Bailey. So sorry if that confused you, unless you happen to have this version of the calculator. Unfortunately, the calculators are all a little different. It's a pain in the butt. Something I don't like about TI is that they change things like every year. Any questions on that? Okay. Let us go to another one. Let me go new share. Okay, I think I'm going to get rid of this one, unless there's questions. Again, I'm not doing everything because we don't have all, you know, I wanted to kind of make it shorter. Yeah, the last answer was 31.0266, which is y minus x. Can you go back to the calculator? Sure. Okay, so let me know if you have any questions on what I put in the calculator. Don't worry about the left. That's not important, because the default is left. Any questions, Bailey? Okay, so now let's go back again. And I'm going to erase all of this. Okay, by the way, if you want to find less than 90, very similar, except you go negative 99999 to 90. Okay, very similar to the greater than 200, except it's negative 9999 for negative infinity. All right, so now let's get rid of this guy. Everybody have some fun. So now it's time for an application. Okay, so here's the application. Suppose that the time until you, or your wife if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. So I want to let you know this doesn't quite work anymore. It used to be normally distributed. It isn't anymore for giving birth. I don't know why. I know we have some nursing majors. That's a hint. So the nursing majors all need to know this. The pre-nursing or whatever you call yourselves. Nursing students, I think. Anyone know? Any questions? Any thoughts? All right, so let me tell you, it's not math. C-sections. So naturally, we actually give, I don't, I'm male, but the women give birth in terms of the time is normally distributed. But now that we have C-sections, that changes everything. So it's not normally distributed anymore, it's cut off. So the doctor will pull it out after a while, basically, which is what a C-section is. Okay, so and the mean 140, that's your, when people say, when are you expecting? That means I'm expecting in 140 days. Does that make sense? Standard deviation 7 days, that kind of tells you that you know that saying you're expecting in 140 days does not mean you're going to have the baby in 140 days. Let's look at part A. Your boss has just scheduled you or your wife for a business trip to China. Okay, is it a good idea to go to China right now if you're pregnant? So we'll look at it. Okay, you or your wife will leave today, and you're going to return in 135 days. Find the probability that your baby will be born in China. Any questions on the question? Any questions on the question? Okay, so as I've been doing all along, the very first step is to draw a picture. And you're used to this picture? Well, that's not the best, but you get the idea. That's a normal normal curve. The mean is this 140. The standard deviation is 7. We want to find out the probability that you'll return in that your baby will be born in China. If the baby is born in China, that means it's born before the 135-day mark. Any questions on the picture? So once you have the picture, it's actually pretty easy. But drawing the picture is essential. And by the way, I will take off points if you don't draw the picture on the midterm and the final. All right, now it's time to get to the calculator. So I go to the calculator, and here I'm given the value of x, and I want to find the probability. So this one, second distribution, it's normal CDF. I hit enter. And my lower, I could either call it that, or if you want, maybe 0, because that's today. You know, the lowest the baby could be born is right now. It turns out it doesn't matter for this problem. And then the upper was 135. Our mean was 7. And our standard deviation, mean was 140. And the standard deviation was 7. Any questions before I hit paste? Okay, I hit paste and I hit enter. So there we have it. It's about a 24% chance. By the way, you think that's good? Would you be okay with that? To have a 124% chance your baby is like born on your business trip? Okay, I hope not, or your marriage isn't going to last very long. Yeah, you better not be okay with that. Okay, so that's not okay. So now let's take a look. We're going to negotiate now. You know, you don't want to quit your job either, so you want to negotiate. Okay, you still have to go to China, but maybe you're going to return so that you have a very small chance of the baby being born. So let's look at part B. So you decide that this is way too risky, and you're going to negotiate with the boss to ensure there's no more than a 1% chance the baby will be born in China. Wouldn't that sound better if there was only 1% chance that that bad things happened? Baby's not going to die born in China, but it's not good. What day should you ask to return for the return date to be? Any questions on the question? Okay, so for this one, we're going to draw the picture. That's always true on all of these. We still have the mean is 140. We have the, we want to find out a 1% chance that the baby will be born in China. So what that means is we know the percent chance, we know the probability, and if you remember probability is area. So what we know is that over here, this area is 0.01. And we want to find this value x. What does this look like? What function of the calculator does this look like? We've done something like it already today. See if you can tell me, type in the chat, say it, whatever. Yeah, this is the inverse norm, or inv norm. So now we're going to use the inv norm feature on the calculator to find the x. So now I'm going to go ahead, and I'm going to go ahead to my calculator. And I'm going to go second, distribution, inv norm. We wanted a 1% chance, 0.01. The mean was 140. The standard deviation was 70. And we paste. And we hit it again. 70, not 7, not 70. I got an extra 0 there. I knew it wasn't negative 22. That wouldn't make any sense. Do it one more time. I just have to get rid of the 0. And that's just 7. One more try. Okay, so now we're going to say we're going to return. I would say on day 123. If you ever want to learn about negotiations, you start low. So you return on day 123, and then you have a 99% chance that you'll be fine. And doesn't that sound a lot more reasonable than a 24% chance of having the baby, to have a 1% chance of the baby in China? Remember, if the baby's born in China, they can't be president of the United States, at least. Any questions on this example? Any questions? Okay, let's try another one. Well, maybe we'll do part C. We got some time. Okay, it's now 138 days later. Okay, and you've heard of this before, right? Is that, what does everybody ask you when you're like got that big bulge in your belly? I don't know if any of you have been pregnant. By the way, I have not been pregnant. They ask you, when's your due date? When's it going to happen? Are you worried? All that kind of stuff. Okay, so it's now 138 days later, and the baby has not been born. By the way, you're back in America. Okay, no problem with that anymore. But if you've had a baby, at this point, you're like just nervous all the time. I just want the baby born. Okay, I have a child, but obviously I didn't give birth. Okay, so find the probability the baby will be born within the next 24 hours. Any questions on the question? Okay, what do we have to do for this one? This one's different than the others. How do we start? Any thoughts? And here's a hint. draw. Not quite. We're actually going to draw, but not yet. We're not ready to draw yet. But it was a good try. The hint is chapter 3. No, that was chapter 2 with standard deviation. The hint is chapter 3. Any thoughts? Yeah, perfect. So Jacqueline gets it. It's a given question, right? We're given the baby hasn't been born yet. So it's a probability that x not quite equals 139. The probability that x equals 139 would be 0 because whenever you have a continuous distribution, the probability of any exact number is always 0. So neither of those are quite right because it's not equals. Does that make sense? So let's write it out. But you got the idea it was given, which is really good. Okay, so let's go ahead and write it out. This is going to be the probability that x is, yeah, that's better. I think I have to hit there. So we want the probability that x is less than 139 given x is greater than 138. Because we know the baby hasn't been born yet. So the delivery time is at least 138 days. We want to find out what's the probability to be less than 139 days. That's tomorrow. So now you got to remember the chapter 3 formula. And whether you remember or not, I'm going to write it. It's a fraction. So that's the probability that both happen. So probability that x is between 138 and 139 divided by the probability that x is greater than 138. Do you remember that little formula? Now we're ready to draw the picture. Okay, and there's going to be two pictures. The numerator picture and the denominator picture. Still have the 140. And for the numerator, we want to be between 138 and 139. Sorry if my writing's not very good, but hopefully you can, I'll say it, between 138 and 139. That's an awful 3. That might be better. Okay, whereas the denominator would draw that picture too. There's your 140. And again, these pictures aren't going to be like perfectly the same because I'm not a good artist, but hopefully you can live with it because I'm not going to get better at art. Sorry. Okay, and then the denominator is greater than 138. I forgot to shade this guy in. So I'm going to go to 138. And then we go ahead and give it some shading. Now we use a calculator and we divide the numerator divided by the denominator. So let's go ahead and do that. I'm going to go to stat. Oh, sorry, not stat. Second distribution. So used to go into stat. And then normal CDF. And If I want between 138 and 139, I go 138. For the lower, the upper was 139. Mu was 140. And sigma was 7. And I paste it and hit enter. And it's about 0.056 or so. Now I do the same thing, but now I want to be greater than 138. So now I'm going to go back to second distribution, the normal CDF. Greater than 138 is 138 to forever. So a whole lot of 9s, 5 or 6. Too many 9s is always okay. And then the rest is the same. I hit enter and enter again. Any questions so far? Okay, now I just divide. So I have 0.05565, how about? Divided by 0.61245. So it's about a 9% chance. Any questions? Any questions on this? Okay, maybe we'll do one more. We got some time. I don't want to go a whole hour and a half, but maybe we'll go an extra 10 minutes. So again, if you have any questions, this is your last chance because it's about to get erased. And it's gone. So we'll do some of these. Since dinner is happening, or dessert for maybe some of you, let's talk about dessert. Okay, suppose that the amount of ice cream that you sell each day, so you have an ice cream store, and let's suppose it's normally distributed with mean 950 ounces and standard deviation 120 ounces. Find the probability that a randomly selected day, you're going to sell between 900 and 1,000 ounces. Okay, any questions on this? First step? Yeah, we draw the picture. So let's go ahead and draw that picture. Whoa, what just happened? I didn't do anything. Let's try it again. Sorry about that. I have no idea what happened. And let's draw our picture. Okay, so what we got is the mean is 950. Okay, we want to sell between 900 and 1,000. Okay, and then we go ahead and we go to our calculator. So hopefully you're getting the idea. There's nothing too new here. It's just a new word problem. And we just go to second distribution. We get a normal CDF. We're going to 900 to 1,000. The mean was 950. The standard deviation was 120. And that's it. And you get about a 32% chance. Any questions on that? All right, let's go and look at the next one. Okay, so the next one is, in the morning you stock your supplies and noticed that you have 1,100 ounces of ice cream in your store. What's the probability you're going to run out by the end of the day? Okay, so again, first step, hopefully you all know. We draw again. And again, the mean is 950. What does it mean to run out? So what does it mean that we ran out of ice cream? Any thoughts? Yeah, means we had customers that wanted totally more than 1,100 ounces. So what we do here is we draw that part of the picture. And as a manager, you hope that probability is low because you don't want to run out. That's awful for a business. So we go ahead and we put in our calculator. So in this case, we're going to get a normal CDF. And this time the lower was 1,100. Just missed it. What's the upper? Yeah, a lot of nines, at least 6. Because you want to be at least 2 more 9s than the number of numbers, number of digits. And same mean, same standard deviation, and we paste. And that's it. It's about 11% probability of running out. Probably not that good as a business, but sometimes you got to live with it. Any questions on that? Okay. Let's go to the very last one of the day. If you want to be 99% certain you're not going to run out of ice cream, how much do you need to have in stock at the beginning of the day? So I think you all know the beginning. We need to draw a picture. $9.50. All right. So what kind of problem is this? What kind of problem is this one? Yeah, this is an inverse. We're given the probability, which is the area under the curve of, so this probability, sorry, is 0.99. Notice it's going to be far right because you stock a lot to be sure you don't run out. And we want to find out X. Okay, so now we go ahead and go to the calculator. And we go to second distribution. We go to inv norm. The area is 0.99. Mu was 950. Sigma was 120. And that's it. We hit paste and enter again. So we need to stock basically 1,230 ounces to be at least 99% sure. So a little more than the 1,100 we're going to stock. Okay, and this is kind of good business management. That's how you make decisions. All right, so let me share again. text. And the secret word of the day is, let me double check. It's actually not even a whole word, it's Z. Okay, because for a standard normal curve, it's the Z is the letter you use. Okay, so that's pretty much all I have to say. Again, today is a little bit shorter than usual, but not ultra short, but a little shorter than usual. I want to let you know, make sure you focus on that project. Okay, project is a big part of your grade. Again, I recommend definitely no more than 6 pages, no more than 20. I mean, if you're writing a 25-page paper, I think you're way overdoing it. Most people, most good papers usually are like between 8 and 10 pages. And that includes the pictures, like the box plot and the stem and leaf, the histogram, and the copy of the statistics. That's typically, again, it's not a requirement number of pages, but there's a lot to write. So if you think you can write it in 1 page, I will tell you you're wrong. That means you're missing a whole lot of stuff in the project. That kind of style is up to you. Again, one of the things I don't tell you how many pages it has to be. So don't try and make it longer by having bigger graphs or something like that. Whatever you think works best for your story, for your presentation to your client. And remember, the entire paper is addressed to the client. Everything you talk about is to the client, not to me, not to you, but to the client. So at the very beginning, identify the client. Don't forget about that. That's all part of the introduction. Identify the client, why the client cares. Those are the kind of things you have to talk about at the very beginning. Why the client hired you or would hire you. That's how you start. Okay, and then again, some people put the graphs at the end, some people put the graphs in the middle, and then as they have a graph and they talk about the graph and they go to the next stuff. Some refer to the graph at the end, but it needs to be in the paper somewhere. Okay, let's do a stop share. Any other questions? Again, this is your chance to ask whatever questions you might have. We stopped a lot earlier than the last few times because one thing I want to be able to answer questions. The other is I don't want to kill everyone because there's a lot to do this week. So it's a little shorter than usual. For online tutoring, is there a way to look back on the, I don't know what a convo is. Ah, conversation. Okay, sorry, I'm not a big texter, so if you use text language, I don't necessarily know what you mean. Apologize for that. Honestly, I really have no idea. This is a weird thing because I'm the professor. I don't use the tutor. I haven't seen what it looks like. You can't get the stats graph that you used in the online tutoring. Yeah, so again, if you can't find it, my recommendation is take lots of notes when you're talking with the tutoring on paper. And then there is a way to look. You get your paper out. Okay, so you use the tutor, Bailey? You've used the tutor? Okay, I can't get the stats graph every time I do it on the sheets, it won't work. Okay, I can't get the stats graph every time I do it on the sheets, it won't work. Oh, okay, so it might be that your browser is so angry that you're going to get a virus, which you won't, by the way, but it's so like paranoid, it doesn't work. So let me show you something that I did because I know that's a problem for some people. Wait, I need to go to share, just a minute. Let's go back to there. Okay, so here's the stat stuff. And again, If I go box plot, it'll probably just show up. But if it gives you warnings, you need you to go, I don't care. I know I'm not going to get a virus, and I won't give you a virus, by the way. And if for some reason you still can't get it, and by the way, if you can get to it, and you can't get back or something, you just do a screenshot, do a screen capture. Okay, using snipping tools or something like that. Okay, but if this doesn't work for you, you kick the X. Well, what happened? Oh, I know what happened. That's what happened. There it is. What I did is I have a stem and leaf creator and a box plot creator. So if you click this, and this, I didn't create this, and you go to it, then you enter your data set and you calculate, and it'll give you a stem and leaf plot. And then you can use that one, and hopefully your computer will allow you to do that. This is called Calculator Soup. There's a whole lot of others that do it too. This is just one I found that doesn't have that anger problem. And let me see. Okay, just a minute. Can't get started. It won't work. But mine says it's not verified. Yeah, the verified again. It's angry about this whole virus thing. It's worried that you might be getting a virus, which you won't, but your computer does. So again, if you go to this, you should be able to get a stem and leaf plot. And I think you have to do it by commas. So I don't know. 3, 4, 5, 5, 6, 6, 7, 7, 8, 9. Let's see if that works. And there you go. There's not much of a stem and leaf plot for this one. Let's do one where it's more interesting. 11, 12, 13, 12, 13, 14, 21, 22, 25. And there's a more interesting stem and leaf plot. Does that make sense? Okay, and you could do the same thing. There's a box plot creator I did, and I didn't, someone else made. And same idea. Here it asks for the minimum, the quartiles, the mean, the median, the maximum, and that you can get from the spreadsheet. It's all there. Yeah, and you just screenshot it. Again, I like snipping tools, but there's other ways of screenshotting. Snipping tools, you can grab the part you want really easily. If you're a Mac user, there's something similar. Okay, any other questions? But these are good questions. Any other questions about the project or anything else? By the way, next week's up for grabs in terms of when we do it. So we did it Monday today, we did Tuesday the last couple weeks. You know, whatever days you want. I should probably double check, but I'm pretty sure I don't have anything going on. That's always important. But I think I'm okay for those. I usually try and keep those evenings good. Actually, I am, that's May 21st. May 21st, I can't do it Tuesday evening. So next week, yeah, I have nothing in the evening on Tuesday, nothing lunchtime Tuesday. And nothing in the evening on Monday either. So any other questions? Let me stop the share so I can see who's all here. Any other questions? Again, as always, if you don't have questions and you want to call it a night, we can do that too. And if you do have questions, we'll be happy. Yeah, so the spreadsheet is a snipping tool, or you can copy and paste. That works too. So if you're going to do the spreadsheet part, you just, I think you just copy and paste it right into Word or Google Docs, and it just copies and pastes in. Just highlight and copy paste. If not, you can always use snipping tool. Any other questions? Jake or Nicholas or Betsy or Rosie, Alejandra, Bailey, Juliana, Constance, Gabriel? Okay. Again, I'll hang until you don't have questions, but be happy to answer questions. Okay. You have a good night too, Betsy and Nicholas and Constance. Thank you. So far, we've never had a some bad connection issue. But please don't wait till the last minute to do the big things, the project and the exam. And we got Juliana and Gabriel. Any questions? I'll give you a minute or so and see if you're still on. If you don't have any questions, I'll call it a night. Okay, thank you, Juliana. And Gabriel, any questions? Or Gabriel? Okay, if there's no questions, we'll call it a good night. And we'll do it again next week. Please ask questions. Remember, Saturday questions won't work because it won't be online. And Friday night doesn't work either by the same idea. I'll be traveling to get to this conference. And we'll call it a night. Have a good night.